If that was 0.001 molar calcium chloride, then the calcium would be 0.001, but your chloride would be twice that many. Y'all see that?
Because there's two of them.
Yeah, because there's two of them. So 0.002 molar calcium chloride. All right, so looking at the problem, see if we can see it. I think I just muted you guys. All right. Accidentally muted you guys.
That's okay.
I unmuted you. Okay, so calculate, that's a little out of focus, but you got a copy of it. Calculate KSP from the molar solubility. And so they tell us the molar solubility of M plus 2, X minus 2. So that's MX. That's going to look like this. This is 7.4, number 1. MX solid would break apart into M plus 2 and X minus 2. And the K for that, the KSP for that would be just my 2 ions, concentration. And they tell us the molar solubility is 4.15 times 10 to the minus 6 molar. That's a really tiny molarity, right? Not very many moles per liter of this are dissolving. That means almost all of it is going to stay as undissolved solid. If you put this in water, you would not even, this is such a small amount of moles, you wouldn't be able to tell that any dissolved. Make sense? So our K is going to be really small because hardly any of it is dissolving. But let's find out how small it's going to be. So however much of this dissolves, that's how much of each one of the ions we're forming. 4.15 times 10 to the minus 6 molar, 4.15 times 10 to the minus 6 molar. So that would, just put that into your K expression. 4.1 times 10 to the minus 6 times itself, which would be that amount squared, and where's my calculator? 1.72 times 10 to the minus 11th. Very small K. That tells us it's not very soluble. We're not forming very much of either one of our ions. Make sense? Yep. Questions, concerns, comments? All right, so let's look at the next one. Next one is the same, only they gave us the solubility in grams per liter instead of in moles per liter. And so, but you have to know what calcium sulfate is. So if you did this, you probably had to look it up. Maybe you remembered what calcium sulfate is, I don't know. So what are we gonna form? We're gonna form a calcium plus 2. Right, use your periodic table to figure out the charges on any ions. And then they're not going to expect you to know sulfate. We already know that. But there it is. Stay focused. All right, so the solubility is 0.66 grams per liter. I have to change that into molar solubility before I can use it. We're going to solve it exactly like this, but we got to change 0.66 grams of calcium sulfate into moles first. How do I change grams to moles?
Divided by the molar mass.
Divided by the molar mass. 1 mole of calcium sulfate has some grams. I wrote it down somewhere, like 190. If you add up 1 calcium, 1 sulfur, 4 oxygens, you get 136.14 grams. And that gives me a molarity of molarity of, there it is, 0.0048. So my grams cancel out, and I'm left with moles per liter. All right, so each one of these is going to be 0.0048 molar. And so K equals 0.0048 squared times itself, which is, where is my answer? Wait a minute, don't tell me we're running out of time. Hey, where are you, Zoom? Zoom is going to cut us off.
Why do it do that?
He doesn't like
2.35.
chemistry.
2.35 times 10 to the minus 5. Y'all get that?
Yep.
All right.
Yeah.
Number 3. Number 3, we're working backwards. We are given the K, and we have to find the molar solubility. And this one's a little different because it has multiple ions. So it's silver sulfate, Ag2SO4. And so that's going to break into, we'll keep your sulfate together. If you have a polyatomic ion, we'll keep it together. But we're going to split that into 2 silver ions. 2 silver plus 1 and 1 sulfate. K was given 1.41 times 10 to the minus 5th. I don't know what the solubility is. That's X. So that's going to be 2X, and that's going to be X, right? So when I plug this into my, it's going to be concentration of silver squared, because I have 2 of them, times the concentration of sulfate. My concentration of silver is 2X squared times X for sulfate. And that would be 4X cubed, right? Equals 1.41 times, y'all better solve it fast. We got 8 minutes before they cut us off. 1.41 times 10 to the minus 5th. Divide it by 4, take the cube root. I don't know what I just did. Cube root of 3.525 10 to the minus 6. All right, so I got X equals 0.015.
Yep.
Yep. So does that really answer my question? Yes, that's my molar solubility. That's the first part.
Oh, grams per liter.
And then, so there's a second part where it says change that into grams per liter. So it'd be 0.015 moles per liter. 1 mole. We're going to multiply that by the molar mass of silver sulfate. And my molar mass calculator. Yeah, whatever that molar mass is.
Oh, I just had my periodic table with me.
Yeah, I'm trying to pull mine up on my phone real quick. But let's look. I'll just tell you what the answer is. So we're just going to multiply that by the molar mass. That's 7.4, number 3. And it should give us 4.75 grams per liter. 4.75 grams per liter. This is 312.5 grams per mole. All right. Y'all good with that?
Yeah.
Hey, these are not bad, especially once you do one or two of them, they're all kind of the same. All right, last one, number 4. Predicting, oh, this one's a little tricky. So we're gonna mix together barium chloride and potassium sulfate, oops, SO4.
Can you
Will
move
a
the page down
precipitate,
just a little bit?
oh yeah,
Everything's being weird.
what?
I'm making fun of Jacob Frazier.
All right, group 1 things are always soluble. We don't worry about that. The real question is this going to form a precipitate?
A precipitate.
Will it form a precipitate? Well, we got to figure out, we basically need to figure out what the moles per liter of this would be, and then compare that to the molar solubility. So find the molarity of barium sulfate and compare it to the molar solubility of barium sulfate. Solubility of BaSO4. So if the concentration is higher than the molar solubility, then a precipitate will form because we'll go higher than the amount that can dissolve. Does that make sense? If it's less than the molar solubility, then all of it will dissolve, and we won't be seeing any solid because
There will be none.
there won't be none. It'll all be ions that'll be dissolved. So like this could form Ba+2 and SO4 2-, but we don't know. So that's the question. Pretty practical information. All right, so how do I find the molarity of this? Well, they give us everything you need for a stoichiometry problem. You'll see that? I have 150 milliliters of, let's change that into liters, 0.15 liters of a 0.00395 moles per liter of that guy. Liters times molarity gives me moles for both of these. I have 550.55 liters times the molarity of my potassium. Oh, wait a minute. Where is my molarity? Oh, there it is. 0.00775 moles per liter of your potassium sulfate. So let me see how many moles I have of each one. 0.00395. That's 5.925 times 10 to the minus 4 moles. And this is 0.00426. All right, this one is smaller. This is my limiting reactant. I cannot make more than I have barium ions, right? So I can only make this much. So for my barium sulfate, I have this many moles of barium. 5.925 times 10 to the minus 4 moles. What's my volume? If I need to figure out its molarity, where do I get the volume from?
Would that be the liters and stuff?
Yeah, it'll be the total volume. I need to add all that volume together.
So you just add 0.15 liters and 0.55 liters.
Yep, that's my total volume. So my total volume is 0.7 liters. Just had to add those together. And then the molarity would be 5.925 times 10 to the minus 4th divided by 0.7 liters. 8.464 times 10 to the minus 4th molar. Okay, I didn't answer the question yet, but I did find the molarity of my barium sulfate. I got
I have to find the solubility?
Yeah, now I got to find the molar solubility and compare that.
So much work.
That is a lot of work. This would be a good problem, right? Because it's got a lot of things going on. It's got stoichiometry. It's got